quantity of ethanol was heated until it reached boiling point. This is being modeled by this particular equation. This equation may be true or it may be false. We need to figure out whether it's an appropriate equation. So the theta here represents the temperature of the ethanol in Celsius, and we also have time here represented by a little t, which is in seconds. The A and B are positive constants, and we are given two lots of information over here. The initial temperature of the ethanol is 18 Celsius, and the other information is that after 10 seconds the temperature of the ethanol is 44 Celsius. And we need to find a complete equation for the model giving the values of A and B. So we have two variables over here, they are A and B. And since there are two variables, we could use simultaneous equations to solve these two variables. So let's start with writing the information that we have. Initially, at t is equal to 0, our temperature is going to be 18 degrees Celsius. And if we substitute it into our equation where theta is equal to A minus B e to the minus 0.7 t, we should get 18 is equal to A minus B e to the minus 0.07 multiplied by 0. And this can be written as 18 is equal to A minus B e to the 0. You're all aware of the fact that e to the 0 is actually 1. Then we could write the final equation as 18 is equal to A minus B. Simple. This is our equation 1. Now, having a look at the second information, when time is equal to 10, our temperature is equal to 44 Celsius. When inserted, we have 44, which is equal to A minus B e to the minus 0.07 times 10. I rewrote those two equations out here. My preferred method here to solve this equation is to subtract the first equation from the second equation. And the reason I'm going to do that is because I have an A and an A over here, which are identical. And because they're identical, they will cancel out for me. So 44, let's start with 44, take away 18 is 26. And now A and take away A will disappear, and I'll just write 0 over here. And then I have minus B e to the minus 0.7. Take away B, which is plus B. And this could be rewritten as 26 equals to B minus B e to the minus 0.7. Now to solve for B, we'll take the B out and say 1 minus e to the minus 0.7, and therefore B must be equal to 26 divided by 1 minus e minus 0.7. And yes, this can be calculated using your calculator to 3 significant figures. It will come up to 51.6. Okay, 3 significant figures. And from this we can calculate A from equation 1, which was 18 is equal to A minus, and now we can substitute B to be 51.6, and A therefore will be 18 plus 51.6. So this makes A to be equal to 69.6. And once again to three significant figures. And all we have left is to substitute this into our original equation, which will be theta is equal to 69.6 take away minus 51.6 e to the minus 0.07 t. Alright, now so this model tells us here that the temperature is equal to 69.6 minus 51 as the time increases. Well, let's just make sure that you understand that this is the temperature. Now we are told that ethanol has a boiling point of 78.7 Celsius. And we're going to use this information to evaluate the model. So let's have a look at this model again. According to this model, the highest temperature that can be achieved is 69.6 Celsius. The reason for this is because e to the minus 7t is always positive because it is an exponential function that looks something like this. As time goes by, it gets smaller, but it is always positive, which means that 69.6 will always be the highest number in this particular model. Now, ethanol has a boiling point of 78, so this model will never reach 78 Celsius. This model never reaches 78 Celsius. In fact, its highest temperature is 69.6 Celsius, and this is much less than 78 Celsius. I hope that this and many of my other videos are useful to you, and if you do find them useful, please subscribe to my channel and give it a thumbs up.